right, good morning, class. So today we're gonna get started and we're gonna go over what's gonna be on Wednesday exam. So remember, pretty much we're all done with quizzes and we're also all done with pretty much homework. Well, pretty much assigning homework. If you still haven't finished the homework, you still have time to do that. But pretty much now what we're gonna do, we're gonna focus on exam number 3. So just remember, today and tomorrow is gonna be review for exam number 3. So if you have questions, that's the time to do so. So today we're gonna go over the pre-exam that I posted on Blackboard. So if you still haven't gone over that, well, we'll go over it today, but you do kind of want to practice on it because just remember, me doing it and you doing it is completely different. Like, you do have to practice on this so that way you can kind of be able to like read the problem, because for the most part, the hardest part is like reading the problem and just labeling everything. So you want to make sure that you spend some time doing the practice again, so that way you can get practice on how to do those stuff. All right. So let's get started. And also practice on class calc. So that way on the test, like, you know where to go for each function in class calc. Because some of you might have issues. Should have access to the pre-exam. Okay, try clicking on it again. All right, try right now. So I'm guessing everybody just barely. All right. All right. All right, so let's go over this pre-exam. So let me go ahead and share my thing. All right, so let's do number 1. So if you look at number 1, it says for the following sketch, a standard normal distribution curve to shade the area, represent the region, and determine the area. All right, so right here we have to shade the normal distribution, and then you have to find the area. So when they say find the area, that's just the other way of saying find the probability. So what we want to do, we want to find the probability. So if you look at it, so one thing they should notice, they gave us a z value. Since they gave us a z value, you should know mean automatically equal to 0, sigma automatically equal to 1, because z is given. So because z is given, you should automatically know mu is equal to 0, sigma is equal to 1. Everybody good with that so far? All right. So let's go ahead and do this one. So if you look at it, it says z is greater than or equal to negative 1.11. So if we go ahead and draw this out, so the mean should be in the middle. So the mean is 0. So if you look at it, we have negative 1.1. So negative 1.11. If you look at the symbol, if you look at it pointing to the right, so since it's pointing to the right, we're going to shade the right-hand side. All right. So far, everybody good with my drawing?
Yeah.
Right. So when we go to class calc, if you look at this and they tell us this is a normal distribution, in class calc, you want to choose the one that says normal distribution. And remember, for class calc, it's going to ask you for the mean, which is 0, and the standard deviation. So that would tell us that the mean is 0, standard deviation 1. But then what you have to do next, in order for it to get you the probability, you have to tell it you want the CDF. So then it's going to give you something that looks like this. So for the CDF, once you press the CDF, what you have to do, you have to tell it what's the lower bound and what's the upper bound. So remember, the lower bound, you have to look at what area you shaded. The lower bound is always the lowest value that you shaded on the left-hand side. Your upper bound will be the highest value that you shaded on the right-hand side. So if you look at this one, my lower bound will be that. Your upper bound will be over here, because that's the lowest value that you shaded, and that's the highest value that you shaded. So the lower bound will be negative 1.11. Upper bound will be infinity, because essentially there's no cutoff, and you keep going and going and going. All right. Everybody go so far with what you're supposed to answer in class calc? All right. So let's go to class calc. All right. So in class calc, let's get the keyboard going. So you first want to hit stats, then you want to go distribution, and then normal distribution. So like I already said prior, you put 0, 1. You hit CDF. CDF, you say the lower bound is negative 1.11. My upper bound is infinity. So if you do this, you get your final answer to be, close enough. It's get to be 0.8665. All right. And that's it for the first problem. So that's it for part A. So any question on how we did part A?
No.
All right. So let's go ahead and let's do part B. So if you look at part B, it says now Z is in between negative 2.67 and negative 1.11. So if we go ahead and draw this, remember 0 is in the middle. So then you go negative 0.11, negative 2.67, and you shade in between. So far, any question in regard to how I shaded that normal distribution?
No, sir.
All right. So if you look at my lower bound will be over here because that's the lowest value that I shaded. My upper bound will be over here. So when I do class calc, what you have to do, once again, normal distribution. You put 0 on 1. So remember, you're putting 0 on 1 because the mean is 0, standard deviation is 1. And then you put CDF. You go, the lower bound is negative 2.67. My upper bound is negative 1.11. So if you enter this in class calc, it should give you your answer. So far, everybody good with this? All right, so let's go over to class calc. All right, so I'm not gonna re-enter this into class calc. All I'm gonna do is pretty much put this. So you go negative 2.67, and then you go positive, well, sorry, negative 1.11, and that's your answer. So your final answer should be 0.1297. And that's your final answer for B. Any question for B? All right. All right. So let's do C. So for C, we're gonna do a little bit different. I'm gonna show you how to draw. I'm gonna show you what you're supposed to enter in class calc, but we're actually not gonna enter in class calc because you should be able to do that. So I'll show you how to enter in class calc, but you're gonna have to enter in class calc and get the answer. All right, so let's do C. So if you look at, here goes the answer for A, here goes the answer for B. So let's do C. So once again, the middle 0. So if you look at it, we want it to be in between negative 1.92 and positive 2.98. So we'll say negative 1.92 is here. We'll say positive 2.98 is over here. So once again, you're gonna shade in between because we want Z to be in between those two values. So you shade in between. All right. So then what you want to do in class calc, you're gonna say normal distribution of 0, 1. And then you're gonna hit CDF. And once you do CDF, you're gonna put that your lower bound is negative 1.92, your upper bound is 2.98. All right. So, and then you enter that in class calc, and then that should give you the answer. But any question in regard to the setup for part C? All right, so let's do D. All right, so for D set probability, well, Z has to be less than or equal to 1.02. So once again, let's go ahead and draw this. So here you go, 1.02. If you look at it, the arrow right here is pointing to the left-hand side, so that means you shade to the left. So in class Cal, once again, you enter normal, distribution, and you put 0, 1. And then for CDF, you put less than or equal to less than. So if you look at it, the lower bound for this one, since there is no lower bound, could keep going to the left-hand side. This is actually negative infinity. And then it goes all the way to positive infinity. Oh, sorry, shouldn't go to positive infinity. Should go to 1.02. So this is the upper bound. All right, but that's how you want to set up part D. Any question in regard to part D? All right. So let's do number 2. So for number 2, it says determine the number Z such that the proportion of the observation that the area less than Z is the standard normal distribution is 0.6. Okay, so if you look at this one right here, what we're trying to do, we're trying to find the Z value. So for this one, they gave us the percent, and what we had to do, we had to translate it to the Z value. So the percent that they gave us is 0.60. So what we want to do, we want to see which Z value is associated with that 0.60. So what we want essentially a Z value that break up the bottom 60% and the top 40%. Because if the left side is 60%, the right side has to be 40%. All right, so let's go ahead and draw this out. So just remember the mean is always in the middle. Since we're trying to find the Z value, the mean should go in the middle. So if you look right here, the reason I know the left-hand side is 60%, because they say less than. So since they say less than means it should be to the left of it. So it means that less than should be 60%. So for this one, if you kind of remember, if you were to cut this off, to the left of it is 50%, to the right of it is 50%. But since I want it to be 60%, that means we have to go a little bit more into this right-hand side. So that way I know we have approximately 60%. So now I'm gonna say this is 60%, this is 40%. Everybody good on where did the 60 and 40 come from? All right. So now we're gonna do how do we enter this into class calc? So in class calc, you first want to do normal distribution. And you want to tell it your mean is 0, standard deviation 1. The reason why you tell it the mean is 0 and standard deviation 1 because you're trying to find the Z value. So you know a Z value, for a Z value, the mean and standard deviation is always going to be 0 and 1. So up next, what we had to do, so for this one, if you look at it, we're not finding the probability because we already found the probability. The probability is 0.60 or 0.6. What we're trying to find the Z value. So anytime we're trying to find the Z value, you have to use the inverse CDF. So one thing you have to remember for the inverse CDF, you always have to give us the probability to the left of the bar that you drew. So you never give it the probability of the right side, you always give it the probability of the left side. So for this one, what's the probability of the left side?
6.
Yeah, 0.6. So we put 0.6 right here. Or you can put 0.60, same thing. It won't change a thing. All right. Everybody good so far with my setup? All right, so let's go over to class count. And let's figure this out. All right, so in class count, you go to stats, you go to distribution, you go to normal distribution, you enter 0, 1. So then you go to stats and you go to distribution. And if you look right here, it says inverse CDF. So to get normal distribution and the inverse CDF, you go to distribution. And then you have to enter 0.6. And if you look at it, give us an answer of 0.2533. So 0.2533. So let's just do that. All right, so your Z value will be 0.2533, and that's your final answer. Any question in regard to the last problem? All right, so let me transfer back to my iPad. All right, so if you look at A, I put my answer right here, because that's your Z value. So let's do B. So if you look at B, it says 15% of all observations from a standard normal distribution are greater than Z. So for this one, we want it to be greater than Z. So greater than Z means that you have to shade the right-hand side. So if I have to shade the right-hand side, it could look something like this. No. So if I have to shade the right-hand side means you shade this portion. So here you go, 0. And if you look at it, you want it to be 15%. So this portion right here, it's gonna be 0.15. Everybody good why I shade the right-hand side, why I put 0.15 there? All right.
Yeah.
So up next, what we're gonna do, we're gonna figure out what should we enter into class count. So in class calc, what we want to do, you want to do normal distribution. You put 0, 1. You do inverse CDF. But remember, you have two options. We could either put 0.85 or 0.15. Which of these two should I put? Should I put 0.85 or should I put 0.15?
0.85.
Yeah, so you want to enter 0.85. Because if you remember, you always want to enter the probability to the left. Because if you enter the probability to the right, what it's going to do, it's going to give you the bottom 15%. So in order for it to give us the top 15%, we have to tell it, okay, give me the Z value that break up the bottom 85%. So this is what I'm going to put into class count. So let's go ahead and enter this into class count. All right, so if you notice, I already have this formula here. So I'm going to keep it, and I'm going to change it from 0.6 to 0.85. All right. And we get our Z value. So we get Z is equal to 1.036. All right. And that's your final answer for B. Any question for B? All right, so let me go ahead and switch over. All right, so let's do 3 now. So for this one, it said 3, let X be a random observation that has a normal distribution with a mean equal to 12 and a standard deviation of sigma equal to 2. Find the area under the normal distribution curve for the following between X is equal to 7.76 and X is equal to 12. So if you notice for this one, pretty much what we have our mean is equal to 12 and we have standard deviation is equal to 2. So for this one, there are 2 ways that you could do. You could either convert the mu and the sigma, and you could convert each X value into a Z value, or pretty much you could just play with them in class calc. So usually the easier way is to use them for class calc. So instead of putting mu as 0, sigma is 1, what we're gonna do, we're gonna put mu as 12, sigma is 2. So let's go ahead and draw this out. So right here, the middle should be 12. So if you look at, we want X to be 7.76. So say 7.76. If you look at, we say X is equal to 12, which is here. And to say the word between, you say in between. All right. Everybody good so far on my shading? All right. So let's go ahead and do class calc. So in class calc, the first thing you want to go ahead and do, you want to do normal distribution. So for the normal distribution right here, you have to be careful because for this one, you have to put mu is equal to 12. You put sigma is equal to 2. Then what you want to go ahead and do, you want to hit CDF. And under CDF, this is going to pop up. So you want to tell it what's the lower bound, what's the upper bound. So for my lower bound, it will be here. For your upper bound, it will be there. So for my lower bound, you put 7.76. Upper bound, you put 12. Everybody good so far on how I set up A?
Yeah.
All right, so let's go ahead and do this in the calculator. So in the calculator, so we'll go ahead, we'll go to stats, we'll go to distribution, we'll go to normal distribution. So we'll say mu is equal to 12, sigma is equal to 2, and then you want to hit CDF. You put 7.76. You hit the upper bound is 12, and that's our probability. So for your final answer, you get 0.48, pretty much 3. So you get 48.3%, and that'll be your answer for A. Any question in regard to A? So let me switch over back to my notes, and let's go to C. All right, so let's do B. So if you look at B, it said between X is equal to 14.48 and X is equal to 16.34. So here goes the middle. The mean is still the middle. So we have 14.48. And you have 16.34. And if you look at the keyword here, it's in between. So you say in between. So then what we want to do, we want to figure out, hey, what do we have to enter into class calc? So it should be the same as the previous one. The only thing they're going to change is my lower bound, my upper bound. Because now my lower bound, in this case, is going to be 14.48. My lower bound, my upper bound should be 16.34. So that's the only thing that's changing, the lower bound, my upper bound, because the mean and standard deviation is still going to be 12 and 2 respectively. So let's go back to class calc and let's switch it off. All right, so I'm gonna switch my lower bound. So my lower bound, say, is 14.48. My upper bound is 16.34. All right, so if you look at it, if you enter that, you get your final answer to be I'm blocking that off, 0.92. And that will be it for that last problem. Any question in regard to this last problem? All right, so we're gonna go ahead, we're gonna finish off Z. We're gonna do C. But for C, we're gonna do a little bit different. I'm gonna show you how to set up in class calc, but I'm not gonna show you like entering into class calc, but I'll give you the answer. So if you look at C, C is pretty much the same thing. You draw this out, you put in the middle 12, you go 8.22, and you get 11.06. So if you look at it, it says between. So between means you say in between. So in class calc, pretty much everything's staying the same. The only thing that's gonna switch is my lower bound, my upper bound. So for my lower bound, we'll put 8.22. For my upper bound, we'll put 11.0612. So I'm gonna go ahead and do that in my calculator. All right, so if you do this in class calc, you should get the answer to be 0.29, or pretty much just 0.29. All right, and that's it for that one. Any question for part C? All right, let's do part D. So for part D, if you look at it, it says to the right of 10.02. So that means we draw this out. The middle should be 12. This should be 10.02. And if you look at it, it says to the right. So to the right, the right-hand side. So that means you shade the right-hand side. So once again, class calc, pretty much the mean and the standard deviation staying the same. The only thing that's gonna switch up is my lower bound, my upper bound. So for my lower bound, we put 10.02. But for your upper bound is all the way, if you look at it, keep going to the right-hand side. So that's going to infinity. So let me see what answer I get for that. There you go, 10.02. And go infinity. So for this one, you get 0.86. 0.8389. So if you do that in class calc, you should be able to get 0.8389. Any question in regard to part D? All right, so let's do part E. So for part E, it says to the left of x is equal to 9.72. So let's go ahead and draw this. So here you go 12. Here you go 9.72, and it says to the left. So since it says to the left, you shade the left-hand side. So since you shaded the left-hand side, once again, class cal, everything gonna stay the same. The only thing that's gonna change is your lower bound, your upper bound. So in this case, your lower bound should be negative infinity. Upper bound should be 9.72. So if you use 9.72, you get 0.1271. And that's your final answer for E. All right, any question in regard to E? All right, so you should know how to use class calc because like the majority of the question you're gonna be using class calc, so you do want to get very accustomed to using class calc. All right, so let's do number 4. So number 4 is essentially gonna be the same thing that we've been doing for the last 3 problems. The only thing different is an actual word problem. So for this one says, according to the U.S. Bureau of Census, students require an average of 6.29 years beyond high school to attain a bachelor degree. Assume the current time to attain a bachelor degree has a normal distribution with a mean of 6.29 years and a standard deviation of 1.1 years. Okay, so first, before we go on and look at the problem, let's look at pretty much what 6.29 and what 1.1 represent. So what does the 6.29 represent?
Population mean?
Perfect. So this represents the population mean. Because remember, for this one, if you look at it, they don't tell us they took a survey of like 20, 30, 40. They're telling you this is the mean for how long it takes after high school to get a bachelor degree. Also, like other keyword here, they use the keyword census. Whenever you see the word census means they gather the entire population, but you don't even need to know that because as long as you see like they don't tell us a sample, you should see that 6.29 is the population mean. So also, if you look at it, they gave a standard deviation of 1.1. Once again, since they don't tell us this is coming from a sample of like 20, 30, or 40, we're just going to assume this is the population standard deviation. All right, so that's my mu and that's sigma. Any question for mu or sigma? All right. So for part A, it says determine the percentage of the time student will require more than 5.19 years to obtain a bachelor degree. All right, so let's go ahead and do this. So we draw this out. You put the mean, 6.29. And if you look at it, it says 5.19. So you put 5.19. 5.19 is smaller than 6.29. So that way you put it to the left-hand side. If you look at it, it says more than 5.19. So you shade the right-hand side. All right, so pretty much we're halfway done. The next step is just entering this into class calc. So one thing you should kind of already notice, if you look at how much I shaded more than half of it. So you should know that your answer should be more than 50% because 50% will be here. But if you look at it, I shaded beyond that. So our answer should be something bigger than 50%. So if your answer is smaller than 50%, you know you did something wrong because it should be greater than 50%. All right, so in class calc, let's go ahead and enter into class calc. So in class calc, what you want to do, you got to do normal distribution. So mean is going to equal to 6.29. Standard deviation going to equal to 1.1. Then if you look at this one, since we want to find the percentage, you're going to do CDF. All right, so for this one, we have to figure out the lower bound and the upper bound. So for the lower bound will be 5.19. The upper bound, if you look at this, if you keep going and going and going, it's going to positive infinity. So in class calc, that's what I'm going to punch in. So let me go over in class calc and punch this in. All right, so we go over here where it says stats. We'll go where it says distribution. We'll go where it says normal distribution. So we'll put mean. Mean is 6.29. We'll put standard deviation, which is 1.1. And then you put CDF. CDF will be 5.19. Cool. And if you look at it, that's our answer. So our final answer will be 0.8413. And that's it for part A. So let me go back to the notes so that we can see what I answered for part A. All right, so for part A, you get 0.8413, and that's it for part A. Any question in regard to part A? All right, so let's do part B. If you look at part B, I'm going to show you how to draw it, how to enter into class calc, but pretty much to get the final answer, you just enter into class calc and get it. Because it's pretty much the same as this. All right, so we go 6.29. So if you look at this one, it says determine the percentage of students that take between 5 and 6 years to obtain a bachelor's degree. So we'll say here go 5, and here goes 6. 5 to 6. And if you look at it, it says between, so you say between it. Right. So for this one, what we want to go ahead and do, we're going to go ahead and figure out how to do it in class calc. So in class calc, we'll do normal distribution. We'll say mean is 6.29. We'll say standard deviation 1.1. We'll do CDF. And you'll say CDF of X is between 5 and 6. So then once you do that in class calc, it should give you the answer for that one. But it shouldn't be relatively different on how we punch it in for A. It should be pretty much the same. All right, but everybody good for B?
Yeah.
Yeah.
Okay. Cool. All right, so let's do C. So it said, in order for a student to receive their bachelor's degree in the fastest 10%, determine the amount of time it will require. All right, so if you look at this one, we already know the percentage, but we don't know what the X value is. So in this one, we're gonna go backward where, oops, sorry about that, where we have the percentage, but we wanna find what is the X value that corresponds to that percentage. So for this one, let's go ahead and get started. So here you go, 6.29. So if it's the fastest, so I'm gonna give you two options. So I can either put this as the fastest. I can say this is the fastest, So let's say this is A, or I could say this is the fastest, and we'll say this is B. So which one would be the fastest, A or B? Cool. All right, we have one person. So that one person is correct. So yeah, so the fastest should be A. Could kind of think about it for this one, you want it to be a shorter time period. Because the shorter the time period is, the better. So for this one, you actually want it to be the bottom 10%. Because if there's the top 10%, that means that they're the slowest 10%. So for this one, the fastest 10% mean that they have to finish it before 6.29 year. So that way you put it on the left-hand side. All right, so let's go ahead and do this next problem. So for this one, we're gonna say normal distribution. Remember, we're doing this in class calc. And what we have to do, we have to give it the mean. So the mean is 6.29, standard deviation is 1.1. But for this one, what you have to remember, since we're trying to find the x value, then you have to do inverse CDF. Oof. And you have to do inverse CDF of the area to the left. So if you look at R, since the area to the left is 10%, we put 0.10. So for this one, this is how you should punch it into class calc. And in a little bit, we'll actually enter that into class calc. But so far, any question on that? All right, so let's go ahead and do this on class calc. All right, so if you look at this, how many use this? Normal distribution 6.29 and 1.1 because it already has a mean and standard deviation. So we're gonna go to stats, we're gonna go to distribution, and we'll do inverse CDF, and we'll put 0.10. And you get x is equal to 4.88. So that means in order to be considered the fastest 10%, you have to finish your bachelor's degree in 4.88 years or less. If you take more than that, you're not on the fastest 10%. But if you actually complete it in shorter amount of time than that, then you'll be considered the fastest 10%. But that's it for that problem. Any question in regard to that problem? Sweet. All right. So if you look right here, I put the answer, x is equal to 4.88. All right, so let's go down. So let's do number 5. So it says score for men on a verbal portion of the SAT-1 test are normally distributed with a mean of 509 and a standard deviation of 112. Randomly select men are given the Columbia review course before taking the SAT-1 test. Assume the course has no effect. If one of the men are randomly selected, determine the probability that their mean score is at least 590. All right, so first let's look into this. And let's look into 509. And let's look into 112. All right, so what does the 509 represent?
Your population mean?
Yeah, perfect. Mean of the population. So it's the mean of the population because if you look at it, they don't tell they took a sample, 20 men or 30 men. They say this is pretty much the mean score for all men. So it's 509. So if you look at 112, what does 112 represent?
Standard deviation.
Yeah, and that's of the population. So let's go to A. So for A, how many men did he randomly select? Well, they only randomly selected one man. Since they only randomly selected one man, pretty much you don't have to adjust your standard deviation. Because if you do 112 divided by square root of 1, it will still be 112. So there's no need to adjust it. So let's go ahead and find this probability. There you go. The middle is 509. So if you look at it, we want their mean score to be at least 590. So 590 is over here. But since it says at least means that's the minimum, but it could be bigger than that. So you shade the right-hand side. So we're gonna do 590 and everything greater than 590. Any question on the shading so far? Okay, no question on the shading. So let's go ahead and enter what should we put in class Cal. So in class Cal, you do normal, distribution, we'll do mean of 509, you do standard deviation of 112. Then since you're trying to find the probability, you have to make sure to do CDF. So if you do CDF, this should pop up into class Cal. So if you look at my lower bound is over here, your upper bound is over here. So for lower bound, you put 590, upper bound, you put infinity. So I'm going to go ahead and punch that into class Cal. So I'm going to go ahead and transfer over to class Cal. So we'll go to stats, we'll go to distribution, we'll go to normal distribution. So you go mean is 590, standard deviation is 112. You hit the CDF option. The lower bound is 590. If you look at my upper bound, is already there. Oops, entered the wrong one, 409. See? So if you look at it, we get our final answer to be 0.2348. And that's it. So that's your final answer for A. So for A, it should be 0.2348. Any question in regard to that?
No, sir.
Oops. All right. So if you look right here, here is the answer. And that's it for A. So let's go ahead and do B. So for B, said if 16 of the men are randomly selected, determine the probability that their mean score is at least 590. So this drawing gonna stay the same. So it's 509, 590. And if you look at those at least, so we still shade the right-hand side. But what's gonna change for this one, it's gonna change how many men are we randomly selecting. Okay, if you look at part A, we randomly selected only one. But if you look at part B, it says 16 of the men are randomly selected. So if 16 of the men are randomly selected, what you wanna go ahead and do, you have to find what mu of X bar is, which is just mu. And you have to find what sigma of X bar is, which is sigma divided by square root of n. So for mu is still gonna be 509. But what's gonna change is your standard deviation, because we're not gonna use 112. You're gonna do 112 divided by square root of 16. And if you do 112 divided by square root of 16, you get 28. So my mean is going to be 509, but your standard deviation, you should switch it over to 28. So you have to remember this. If you do change the sample size, your standard deviation has to reflect that you change the sample size. So when we go to class calc, here, let's do a different color. We'll say normal distribution. You say mean of 509. You say standard deviation of 28. Then you say CDF. And for CDF, you say from 590 all the way to infinity. And that'll be it for that, how you set it up. So kind of notice the difference between A and B. The only thing that changes is the 112 and the 28. Because you have to adjust that you randomly selected 16 men versus only randomly selecting one. So let's go ahead and find the probability for this. All right, so if you look at, I already have it all set up from part A. So all I'm gonna do is change that from 112 to 28. All right, and that's my new probability. So we'll say 0.0019. And that's your final answer for part B. So for part B is less than 1%. Any question in regard to part B?
No, sir.
All right, let's do part C. So if you look at part C, it said if 50 of the men are randomly selected, determine the probability that their mean score is between 520 and 550. So here you go, 509. So now we want to do between 520 and 550. So 520, we'll say is right over here. So let me put 520 here. And then you have 550, we'll say is right over here. If you look, it says between, so you say in between. So for this one, if you look at it, now we are changing the sample size again. So now instead of it being 16, now we're saying that's 50. So we have to find mu of x bar, which is still 509, but we have to find sigma of x bar, which is going to be 112 divided by square root of 50. They do 112 divided by square root of 50. And it's 15.84. So that's my new standard deviation. So instead of putting 28, we had to change it to 15.84. So let's do class calc. So in class calc, we'll enter normal distribution. You do mean of 509, but now you have to enter standard deviation of 15.84. And then you do CDF. And then we'll do the lower bound and the upper bound. The lower bound should be 520, upper bound should be 550. Any question on the lower bound, the upper bound, or why my standard deviation changed to 15.84? Right, so let's go ahead and do this in class calc. So if you look in class calc, I'm going to change this from 28 to 15.84. And you should change that to 520 to 550. So the probability that somebody scored between 520 and 550 is 0.2389. 0.2389. And that's it in regard to the last problem. Any question in regard to that last prompt? All right, so we're all done with C. Cool. All right, so we're all done with all of these problems. So let's go on to number 7. So, sorry, number 6. So it says the speed of all cars traveling on a stretch of interstate highway I-5 are normally distributed with a mean of 68 miles per the hour and a standard deviation of 3 miles per the hour. Determine the probability that the mean speed of a random sample of 16 cars traveling on the stretch of this intersection highway is, and then we have to find that. All right, so if you look at it, they gave us 68 and then they gave us 3. So we have to figure out what 68 and what 3 is. So we'll say 68 and we'll say 3. All right, so if you look at 68, they tell us this is the mean. So this is the mean. So we'll say this is mu. Because they don't tell us that they took a sample in order to get there. They're saying this is the mean speed for this highway. So we're gonna say mu is equal to 68, and then we're gonna say standard deviation is equal to 3. So that's my mu and that's my sigma. If you look at this one, then they later on say that we want to take a sample size of so many people. What is the sample size that they want to take?
$16.
Yeah, 16. So n is equal to 16. So n is equal to 16 for this one. So if you look at part A, it says slower than 66 miles per the hour. So let's go ahead and draw this out. So the middle should be 68. If you look at it, we want it to be slower than 66. So here goes 66. They put 66. If they say slower, slower means you shade the left-hand side. All right, so far that's my drawing. So since we want to find the probability of these 16 cars to be slower than 66 miles per the hour, what we have to do, we first have to convert our sigma, and we have to adjust it because the sigma that we have there for equal to 3, that's if we're randomly selecting one car. But if we're randomly selecting 16 car, we have to adjust the standard deviation. Oops, sorry about that. So we have to find 3 divided by square root of 16. So if you do 3 divided by square root of 16, you actually get 0.75. Everybody good how we get 0.75?
Yes, sir.
All right. So let's go ahead and see where we're going to enter in class count. So in class count, so you're going to do normal, oops, distribution. So the mean will still be the same of 68. 68, but your standard deviation would change to 0.75. So we're going to take normal distribution of 68, which is our mean, and 0.75, which is our standard deviation. And then what we have to do, we have to tell her what the lower bound is and what the upper bound is. So for the lower bound, we're going to put, where's my negative? Negative infinity. And we'll put less than x to less than. And then if you look at my upper bound, the highest value that gets shaded, which is 66. So on class calc, we're going to enter normal distribution 68, comma 0.75. The 0.75 is our adjusted standard deviation, is our standard error. And then for our lower bound and upper bound, we're going to put from negative infinity all the way to positive 66. All right, so let's go ahead and go to class calc. All right, so for class calc, we're going to go to stats, we're going to go to distribution, we're going to go to the normal distribution. We'll put the mean is 68. You put a standard deviation, which is 0.75. And then we're going to say CDF. And we'll put that the lower bound negative infinity, which is already there, and then you put 66. So if you look at your final answer should be 0.0038. And that will be it for part A. Any question for part A? All right, let's do part B. All right, so if you look at part B, it says faster than 70 mph. So we're still dealing with the 16. The only thing that's changing is what we're trying to find the probability for. So we go 68, and if you look at 70, and then for this one it says more than or faster than 70 mph, so that means you shade the right-hand side. So far that's our drawing. So then what we're gonna go ahead and do in class calc, we're gonna say in class calc, we're going to do normal distribution. And we're going to say mean is equal to 68. Sigma is equal to 0.75. And then for our CDF, now we're going to select that our lower bound is 70 and our upper bound is infinity. So let's go ahead and do that in class calc. So if you look at it, I already have the normal distribution of 68 and 0.75, so that's fine. The only thing I have to do, you change my lower bound to 70. And then you change this to infinity, which is 0.0038. 0.0038. And that's your final answer for part B. Any question for part B? All right. So let's do part C. For part C, I'll show you how to do it in class calc, and then I'll let you enter into class calc. So right here is 68, then here is 66, right here is 70. So we want from 66 to 70, so that means shade in between. So we're still gonna do class calc, but you're gonna do normal distribution. So the mean is 68, standard deviation is 0.75. You're gonna press CDF because you wanna find the probability. And then you say that the lower bound should be 66 all the way to 70. And that's gonna be, and then in class calc, once you do that, it should give you some answer for that. But that's how you want to do part C. So for part C, the only thing that changes, since you want the middle, your lower bound will be 66, your upper bound will be 70. Any question on how to do C? All right, so let's do 7, and that will be it for today. And then we'll finish off the review tomorrow. So for this one says, suppose a student plan to guess on all questions on a multiple choice exam with for 4 choices per question. If the exam contains 10 questions. So for this one, if you look at it, you tell us n is equal to 10. So they tell us that this person get a guess on all of the questions. So since they're guessing, pretty much they're not really have any inclination on like which of the options are correct. So since they're guessing, the probability, so the probability they guess correct will be 1 out of 4. So the way that I get the 1 out of 4, because if you look at it, they tell you there are 4 choices. So there are 4 choices. That mean you have A, B, C, and you have D as your option. But if you look at it, not all 4 of them will be correct. Only 1 of the 4 will be correct. So that's how you get P is equal to 1 out of 4. So the next thing which you kind of have to see that this is the binomial distribution. And the reason why it's a binomial distribution, because they tell you how many times they're doing the trial, and they tell you the probability of that trial being a success. So they tell you the probability of the trial being a success is 1 out of 4. So the probability of the trial being a failure will be 3 out of 4. Any question on how we identify this to be a binomial distribution? All right. So let's do A. So for A, it says determine the probability that the student will get at least 7 questions or 7 correct on this exam. All right. All right, so we want them to get at least 7 correct on the exam. So if they get at least 7 correct on the exam, how many questions can they get correct?
Seven or more.
Yeah, 7 or more. So they could get 7, 8, 9, and 10. So what we have to do, we have to find the probability of this. So we have to find the probability a student that is guessing on this quiz gets 7 correct, 8 correct, 9 correct, or 10 correct. So what we're gonna do, we're gonna use class calc for this. So let me go over to class calc. So remember, this is the binomial distribution. So I want to go to stats, go to distribution, and do a binomial distribution. So if you look at n is equal to 10. If you look at it now, that's me for p, which is 0.25. Cool. All right. And anytime you want to find a range, so what I mean by a range, if you need to find multiple x value, you want to use CDF, because CDF gives you the option to choose multiple value. So if you look at ours, we want it to be between 7 to 10, because we want 7, 8, 9, and 10. So pretty much 7 to 10. So I'm going to tell them the lower bound is 7. The upper bound is 10. So if you look at that, we get 0.0035. And that will be your final answer for part A. Any question for part A? All right, so let me switch back to my notes. So that's the probability a person that's guessing on this exam will get at least 7 questions correct, or 7 correct on the exam. So not very likely. All right, so for part B, it says determine the probability that the student will get at most 4 correct on the exam. So for this one, the keyword here is at most. At most means that's the maximum. So saying at most, we want them to get 4 questions correct, but it's okay they get like 3 questions correct, or 2 questions correct, or 1 question correct, or even 0 question correct. So that what at most mean. So at most mean you could get 0, 1, 2, 3, and 4 questions correct. So what we're gonna do now, we're gonna find the probability of this. So we're gonna go back to class count. But any question on how I got x is equal to 0 all the way through 4? Right, so let's go ahead and go to class count. So in class count, we're gonna change the lower bound. Lower bound will be 0, upper bound will be 4. So if you look right here, you'll get 0.9218. So 0.921, and then you can round the 8 to a 9. And that will be your final answer for that one. Any question on B? All right, so let's do C. All right, so now for C, here. All right, so for part C, it said, do you think that by guessing on a multiple choice exam, you will pass? So if you look at it, like in order for you to pass, you need to get 7 or higher. And if you look at the probability of you getting 7 or higher on this quiz, on this exam, if you're guessing, it's 0.0035. So for this one, we'll say no, it does not look all right, so I'll say no, it does not look like a person will pass by just guessing since the probability is so low. And that's it for that last prompt. All right. Any question in regard to the last prompt? All right. All right, so we'll stop right here. So we'll leave this for tomorrow. So we'll leave this for Tuesday. And that's August the 3rd. All right. So that's pretty much it for today's class. So we'll leave it there. So just remember, if you do have any question, I'll have office hours, so that way you can ask any question about anything. So I'll have office hour. Once I close this out, I'll open up the office hour for it. And that way you could just ask questions. So just remember, like you do, like today, there's no quiz, there's no homework. So do practice on the practice exam. Because technically you already know everything on this practice exam. So you should be able to practice on it. So do practice on it. So that way if something doesn't click, tomorrow, like I could go over it. And that way you could see why you weren't able to do it. Because just remember on Wednesday, you're gonna have your third exam, and then on Thursday, we're gonna review for the final, and then on Friday, you're gonna have your final. So you do kind of want to start revving up for these two tests because like these two tests are going to be difficult if you don't study. So do practice on the practice exam and do practice on the practice exam for the final because you do want to start practicing for that. All right, any question?
No.
All right, cool. And Erica, I'll send you the link for that way we can meet up today at 12 p.m. So that way we can meet up at 12. All right, guys. So that's it for today. I'll see everybody.